Exercise 11.3. First question. We are asked for two things: direction cosines to the normal, to the plane, and distance from the origin. Distance from origin. These two things we are asked there. Okay, so let's see the first sub question. The equation is z equals to 2, which I can rewrite like this: 0 into x plus 0 into y plus z equals to 2. So what's the normal? Direction of the normal, that is coefficients of x, y and z, which is 0, 0, 1, which is nothing but you can write 0 into I cap plus 0 into j cap plus k cap if you want to write in form of vector components. Now you are asked for direction cosines. This is indirectly unit vector if you remember. So let's find its magnitude. It has to be 1. So therefore direction cosines will be direction cosines of the normal of the vector n, that is 0 upon 1 which is 0, comma 0 upon 1 which is 0, and 1 upon 1 which is 1. Now distance from the origin. So there are two ways. The one way is you express this equation, express the given equation in this form: vector r dot n cap equals to p. So p gives us the distance from the origin. Now r dot means variable x, y, z, and normal should be unit vector. Now it is already unit, so the above equation is already in this form. I can write here r dot, what is normal here? That is nothing but the, here just k cap, that is equals to, here you have 2. This is normal. This equation is already in this form, remember, because this is already unit vector. And then p represent the distance from the origin. Okay. Or alternatively you can use this formula also. Or we did this, if you remember, distance from the origin, that's equals to, if you remember, modulus of d upon root of a square plus b square plus c square. Just recall the theory. What's d here? You take 2 on the other side, so it's minus 2 upon, this is a square which is 0. A square means this, plus 0 plus 1. So in turn you will get the d. We have used one of the earlier formula, remember. Either you can do this way or this way, whichever we like. Which formula we have used? If you remember, just I'm reminding you, if this is the equation of the plane, ax plus by plus cz plus d equals to 0, then the distance from the origin, let me call this small p, which is modulus of d upon coefficients of x, y and z, which is nothing but a square plus b square plus c square. This is what I have used here, right? We already stated in the theory portion. Okay, let's see second question. You will realize further. Question number 2 here. There the equation of the plane will be, what's the equation of the plane there? X plus y plus z equals to 1. The second sub question there. X plus y plus z equals to 1. This is the equation of the plane. So what's the normal to the plane here? So normal is this vector n, that's the coefficients of x, y and z, which is 1, 1, 1. 1, 1 and 1. So this is a normal. Now is this unit? No. So find its magnitude. What is its magnitude? Which is nothing but the root of 1 square plus 1 square plus 1 square, which is root 3. Okay. So therefore, direction cosines of the normal, direction cosines of the normal n, that is equals to, there's a definition, vector upon its magnitude, that this is 1 by root 3 comma 1 by root 3 comma 1 by root 3. This is cos alpha, cos beta, and cosine gamma. Fine. Now, to find the distance from the origin, what you need to do? You need to express this equation in which form? Now express given equation in the form of which form? Vector r dot n cap, that is this one. This is n cap, equals to small p. Right? Now here, what are the coefficients? 1, 1, 1. You need 1 by root 3, 1 by root 3, 1 by root 3. So I'll just divide this equation by root 3 on both the sides. So x by root 3 plus y by root 3 plus z by root 3 equals to 1 by root 3. So I can rewrite now vector r dot, what is this? This is n cap equals to small p. So the p will be root 3 here. Right? Where r cap, r vector r is always x, y, z. What is n cap? That is 1 by root 3, 1 by root 3, 1 by root 3. Right? This is just for your information. So here, what is p? That is 1 by root 3, perpendicular distance from the origin. Or again, I'm emphasizing, you can use this formula. Perpendicular distance p equals to modulus of d upon under root a square plus b square plus c square. Choice is yours. Either you can do this way or you can find this way also. What's modulus of d? That's modulus of -1, taking 1 on the left hand side. Okay, just constant upon root of a square plus b square plus c square. That is 1 plus 1 plus 1. So in turn you are getting 1 by root 3. That is perpendicular distance. The one way is you express the given equation of the plane in this form, normal form, if you remember. Vector r dot here, n cap equals to small p. Right? Here it is just this equation represent this form only, remember. This is vector r dot normal equals to 1. So 1 is not the perpendicular distance, remember. This vector, normal vector, should be converted into which vector? The unit vector, remember. And that's what I did here. Then this right hand side constant represent the perpendicular distance from the origin. Do you understand the difference between this form and this form? Right? Here, this is just a normal to the plane, and here this is a unit vector, which is direction cosines. So to do that, I just divided the entire equation by root 3. So this equation now reduced to this form. And then that p represent 1 by root 3. Okay. I'll do one more. Let's see. Next one. Third sub-question. What is that third sub-question? Their equation is this. 2x plus 3y minus z equals to 5. This is equation of the plane. Ax plus by plus cz plus d equals to d equals to 0. So normal to the plane here. Normal to the plane would be coefficients 2, 3 and minus 1. 2, 3 and minus 1. Okay. Now this is not a unit, you can see directly by observation. So we need to get its magnitude. So here you have 4 plus 9 plus 1. That's the magnitude. Root of a square plus b square plus c square. So which is nothing but the root 14. So therefore n cap, which is direction cosines, if you remember, that is vector upon its magnitude. what is this? This is 2 by root 14, comma 3 by root 14, comma minus 1 by root 14. Right? This represent what? Direction cosines. Direction cosines to the normal to the plane. Fine. Now, next important step is what? We want the perpendicular distance from the origin. Now you know that this is in which form? Vector r dot normal equals to 5. Right? So we now, instead of this, here we need unit vector. So we express in which form? We express given equation in normal, your vector r dot normal cap equals to small p. Now to do this, we need to divide the given equations by root 14 because we need to convert this 2, 3 minus 1 into unit vector. So therefore, 2 by root 14 x plus 3 by root 14 y minus 1 by root 14 z equals to 5 by root 14. So this you can write vector r dot what is this? 2 by root 14 I cap plus 3 by root 14 j cap minus 1 by root 14 k cap. This is a dot product, remember, equals to 5 by root 14. So from this, here we have vector r dot, this is n cap, you know, equals to small p. So this is a perpendicular distance. So what's a perpendicular distance? Which is 5 by root 14. Same way you can do the fourth sub question D. There in the fourth sub question, what is the direction of the normal? I mean, what's the normal there? Just see the equation of the plane. The normal to the plane will be, x is not there, remember. So you have 0, comma 5, comma even z is also not there, so 0, remember. This is normal to the plane. And now continue further. In the next question, you are given, find a vector equation of a plane which is at a distance 7 units from the origin and normal you are given. Okay, so here distance from the origin, which I call the small p, which is 7, that's given to you. Normal to the plane, what's a normal to the plane? 3i plus 5j minus 6k. So we use that normal form, you know, we use this form r dot normal n cap equals to p. This form we are going to use. Why we are going to use this form? Because we are given the perpendicular distance from the origin. So we just need to make the unit vector here. So let's get its magnitude. So it is root of 9 plus 25 plus 36. Right? And which would be nothing but, what is this? This is, I suppose, root 70. Which is nothing but the root 70. So your n cap will be 3 by root 70 I plus 5 by root 70 j minus 6 by root 70 k. Fine. This is nothing but the n cap. And therefore the required plane means what? Plane whose normal is this and the distance from the origin equals to 7 is this. Vector r dot n cap equals to small p. So r is variable vector, we keep as it is. What is n cap? Which I just place here. 3 by root 70 I cap plus 5 by root 70 j cap minus 6 by root 70 k cap equals to small p. What is small p? That's a 7. So in this form we need to keep remember. Okay. What about next question? In all next questions, there are 3 sub-questions. You need to express in the Cartesian form. That is, instead of just vector r, you take x, y, z, finished. So for first sub-question, here we have this r dot I cap plus j cap minus k cap equals to 2. Let this vector r equals to x comma y comma z. I'll just place here. So this is xyz dot, what is this? You know here 1 minus 1 equals to 2. I'll use just dot product. This into this which is x, this into this which is y, this into this which is minus z equals to 2. That's the required plane in the Cartesian form. Third sub question, you are given this plane in form of vector. This represent, we know, normal. So just placing here components which is x, y, z dot, what is this? Here s minus 2t, comma 3 minus t, comma 2s plus t equals to 15. So do the corresponding product. This into this which is s minus 2t into x plus 3 minus t into y plus 2s plus t into z equals to 15. This is required equation of the plane in form of Cartesian. Next question, question number 4. For the next fourth question, that's again very important question here. What you want? You want the foot of the perpendicular drawn from the origin to the given planes. The first plane is given by this expression. Now for that you just need to go back to this theory. Which theory? Which we already used in earlier questions. Equation of the plane on which perpendicular from the origin is drawn having the length p. That is this diagram. Now what's the normal to the plane here, as I mentioned? That is this vector ON. And n is the foot of the perpendicular here. So this is normal as I told you here. And n is the foot of the perpendicular. So foot of the perpendicular means this vector ON. So we need this, remember. Now what is vector ON? That is small p into n cap. What's small p? Perpendicular distance from the origin. This is a scalar product. This is a scalar and this is unit vector. So we need to find this. In all next 4 sub questions, you are going to do this. Perpendicular distance from the origin and n cap. P into n cap. This is scalar product. This is what we want to do. This represent foot of the perpendicular. Foot of the perpendicular from where? Origin, remember. From origin here. So this is what we need to do in the next 4 sub questions. Okay, so to get the small p, you need to express in which form? This form, remember, given plane. So I'll be doing this now, which we did number of times. So here normal to this plane is equals to 2, 3 and 4. That's a normal to the plane. Make it unit, so unit its magnitude. What is its magnitude? That is 4 plus 9 plus 16. That's nothing but the root 29. Okay, so therefore n cap, what is n cap? Which is nothing but here 2 by root 29, comma 3 by root 29, comma 4 by root 29. This is n cap, vector upon its magnitude. Here n cap is this. Now express the plane in which form now? So express given equation in the form of which form? R dot n cap equals to P. So we'll get the P from there. That's a perpendicular distance. Or you can do directly also, whichever you can do. So to express in this form, I need to divide this expression by root 29. So if I divide by root 29, clearly you can see that the P is, take constant on the other side, 12 by root 29. So this is perpendicular distance. This is n cap. Therefore, foot of the perpendicular from where? From origin, that is equals to small p into n cap. Small p is 12 by root 29. So what we'll get from this? 12 by root 29 to that scalar product, that is n 12 by root 29, comma 3 by root 29, comma 4 by root 29. So from this we'll get here 24 by 29, comma 36 by 29, comma 48 by 29. This is nothing but the foot of the perpendicular from the origin, that is this vector ON, that is this point, point N, this vector ON, as we discussed earlier. So I did just this much. You need to do everywhere this much only. P into n cap. P means perpendicular distance here. I'll do one more sub question here. Let's do second one. Second question. Their plane is given by which one? 3y plus 4z minus 6 equals to 0. So what is normal n? Which is x is not there. So 0, 3, 4. Get its magnitude. So what is its magnitude? Which is 0 plus 9 plus 16. Which is nothing but 5 here. Therefore n cap unit vector will be here 0, 3 by 5, 4 by 5. That's n cap. And small p you can do by that formula also, as I mentioned, if you remember, modulus d upon root of a square plus b square plus c square. Question number 1. Modulus d means your modulus of 6, which is your in turn 6 upon, what is this? This is nothing but 0 plus 9 plus 16. 0 plus 9 plus 16, which is in turn 5, so it is just 6 by 5. And then finally, the foot of the perpendicular from origin to the plane, that is equals to p into n cap. What's p here? 6 by 5. What is vector n? 0, 3 by 5, 4 by 5. So you have 0, this is 18 by 25, 24 by 25. This represents the foot of the perpendicular. Fine, I hope now this is clear to you. In first 4 questions indirectly we used that normal form only. Now let's see the fifth question. Question number 5. What's fifth question? You want the vector and the Cartesian equations of the plane. Okay. So to get the equation of the plane, you need 2 things. Either normal to the plane and fixed point. There's one way of getting the equation of the plane. Or you must have how many points? 3 points. 3 distinct known collinear points. If you are given 3 different points, you can get the equation of the plane. or you must have the normal and the point on the plane, remember. So in the first sub question here, what's given to you? The fixed point, that is vector A you are given. What is that? 1, 0, minus 2. This is given to you. And what's the normal to the plane? Normal to the plane is given by what? I cap plus j cap minus k cap, which is nothing but the 1, 1 and minus 1. This is a normal, this is a fixed point. So which form you are going to use? Just recall the form. If you remember, the equation of the plane in this case, equation of the plane, this case, which is vector r minus vector a dot normal equals to 0. This is the form. Just go back to theory. So which you can write directly like this: r dot n equals to vector a dot n. Just have opened the bracket. What is r dot n? R means x, y, z. Normally you know. So if I use the dot product, what will get here? Or let me write one more step, no problem. This is x, y, z. What's normal to the plane? Which is 1, 1, minus 1. A. What is A? That's given to you, which is 1, 0, minus 2, dot. What is normal? 1, 1, 1. So x into 1 plus y minus z equals to 1 into 1, 1. This is 0 and this is minus 2. So we'll get the x plus y minus z plus 1 equals to 0. This is the Cartesian form. And how do we write this is Cartesian form. How do we write the vector form? The vector form, you know, it is r dot n equals to that constant d. So r dot, what is n? N is normal, which is nothing but what here? What's a normal? You know, I cap plus j cap minus k cap equals to d. D is constant, you know, that's minus 1. That's a vector form. So I'm sorry, here it should be minus 1. So minus 1 gives us plus 3 here. So this is equals to 3, remember. And here also we'll get the equals to 3. Even you can write the vector form directly like this also. In this form also you can write the vector form. Or this is also correct. Or you can write like this also. Vector r minus fixed point in the vector form. What is that fixed point in the vector form? You know, it is I cap minus 2k cap dot normal. What's a normal here? Normal to the plane, which is, you know, I cap plus j cap minus k cap equals to 0. Both are correct. Either you can express in this form, backside you are given this form, or in this form, whichever you write. I'm talking about a vector form. Cartesian form you need to do in this form. Fine. Next, sixth question. There you are given 3 points and you want to get the equation of the plane. So let's go to second question there. The points are this. I'll call that as vector A here, which is 1, 1, 0. Vector B here, which is 1, 2, 1. And vector C here, which is given by minus 2, 2 and 1. These 3 points you are given. 1, 1, 0, 1, 2, 1 and minus 2, 2. I'm sorry, here minus 1. Okay, now equation of the plane in this case, you know, equation of the plane is vector r minus vector a dot, if you remember, b minus a cross c minus a. That's vector form. And once we do this, we can express even in Cartesian form also, right? If you just go back to the theory portion, you will realize here. Fine. So here vector A is known to you. Which one? That is here 1 1 0. You need to find this and their cross product, remember. So this is indirectly normal. Now normally when you have dot and cross, it always represent determinant. So I'll just write in form of determinant. So there the first row is, this is the first row, this is the first row, this represent the second row, and this represent the third row, remember. When you have dot and cross, cross is always determinant, you know, but here with dot, this is just first row. So I have therefore determinant, what's the first row here? That is r minus a. R means x, y, z. So x minus 1, y minus 1, z minus 0, which is z. What's the second row? B minus a, remember. So have a look there, seriously. B minus a, which is 0, 2 minus 1, which is 1, and 1 minus 0, which is 1. And what about the last row? That is C minus a. What about C minus a? Minus 3, this is 1, and this is minus 1. I repeat, what is this? This is nothing but which vector? R minus a. R means x, y, z, you know now very well. So what will get? X minus 1, y minus 1, z minus 0. What is this? This is nothing but the vector b minus vector a. So b minus a. That is 0, here 1, and here 1 minus 0, which is 1. And what is this? This is c minus a, remember. C minus a. This is minus 3, 1, and minus 1. Now we just expand, so we'll get the required Cartesian form. X minus 1 into, what we'll get here? Minus 1, which is minus 2. Minus y minus 1 into, this is 0 here, plus 3. So it is just 3. Plus z into, this is 0. Here this is 0 plus 3, which is 3. Okay, so let's simplify this. This is minus 2x plus 2 minus 3y minus 3 plus 3z equals to 0. So over here, sorry, this will be plus 3 here once you open the bracket. So you have minus 2x minus 3y plus 3z. This is plus y equals to 0. You can just take minus common. So I'll get the 2x plus 3y minus 3z minus 5 equals to 0. This is the required plane, right? Required plane which passes through the given 3 points. Okay, first sub question you can try. Now next question, 7th question. The 7th question, what is asked? Find the 3 intercepts of this plane. So just recall this equation of the plane which has 3 intercepts: x upon a plus y upon b plus z upon c equals to 1, where a, b, and c are intercepts. So we need to express the given equation in this form. Right hand side should be 1, remember. That's what you need to see here. So here given plane is this. Given plane is 2x plus y minus z equals to 5. Now I need 1 here, and coefficient of x should be here 1 in the numerator. So I write 2 by 5 into x, 1 by 5 into y minus 1 by 5 into z equals to 1 dividing by 5, which I can in turn rewrite like this: 5 by 2, you know, plus y by 5 plus here z upon minus 5 equals to 1. So you just compare this expression with the standard equation of the plane. So we'll get the three intercepts, right? So intercepts are here, first one is 5 by 2 comma here 5 and minus 5, right? These are the three intercepts. What we did, we have just converted the given plane in this form. So right hand side should be 1, so dividing by 5 here, and then just I have tried to express in this form, so you will get these three intercepts. Okay.